Here's my explanation and example problem for constant pressure calorimetry. So I chose problem 51 from chapter 6 in the Chem textbook, and I synthesized the important information here. We have 50 milliliters of a 0.1 molarity AgNO3 as part of our solution. We are also given that 50 milliliters of 0.1 molarity HCl is also used. And these two come together to create Ag plus aqueous plus Cl minus aqueous, which will yield AgCl in the solid form. We are also told that for the solution, the initial temperature is 22.6 degrees Celsius and the final temperature is 23.4 degrees Celsius. We are also told that the combined mass of the solution is 100.0 grams and the specific heat capacity is 4.18 joules per degrees Celsius times grams. We also know that from this information, and seeing as we're trying to find the constant pressure calorimetry, we need to use the equation E equals mc delta T. E being the heat, which we are trying to find in this problem. We're trying to find the heat of the solution. So the heat is equal to the mass in grams times the specific heat capacity times the change in temperature. So we are given all this information. The E is equal to 100 grams because the combined mass of the solution is 100 grams times the specific heat capacity of 4.18 joules per degrees Kelvin times grams, and then times the change in temperature. So the final minus initial, final being 23.4 minus initial 22.6, which will be 0.8 degrees and change. And then you plug this in your calculator and you will get 334.4 joules released in heat, or you can write this as negative 334.4 joules, because the reaction is exothermic, and we can see that because the final temperature has increased from the initial, meaning that it's releasing heat and thus exothermic. So from that, what we can do is we see that the problem asks us actually to find the heat in kilojoules per mole of AgCl. And we have just found the joules, so now we need to find kilojoules. And we do that by doing the kilojoules to joule ratio, which is 1 kilojoule in every 1,000 joules. So now we are in the kilojoules, but now we also need to have this over moles of AgCl. And to find moles of AgCl, it's a simple limiting reactant stoichiometry problem with the 50 milliliters of 0.1 molarity AgNO3 and 50 milliliters of 0.1 molarity HCl coming together, and from that we can find the moles of it, which would be 0.005 moles of each kind, meaning that you can use either one as the limiting reactant in this case. So, and then from there we see the mole-to-mole ratio, which is just 1 to 1. So in the end, it's 0.005 moles of AgCl being produced. And then from there, we multiply this all together and you get negative 66.88 kilojoules per mole as our answer. And then also part of this topic is coffee cup calorimetry. So I have here a diagram for it, and a coffee cup calorimeter is consisting of two nested styrofoam cups, so one inside the other, an insulated stopper to keep the heat in, a stirrer to ensure that the solution is completely aqueous, so in other words, the solid that you put in no longer is a solid and rather has dissolved, and then a thermometer so you can find the change in temperature. And so a coffee cup calorimetry usually involves water, and by carrying out a reaction in aqueous solution in a simple calorimeter such as this one right here, one can indirectly measure heat change for the system by measuring the heat change for the water in the calorimeter, meaning that instead of actually finding the heat change for the solution, we're finding the heat change of the water, which in theory will be equal to the heat change of the solution. This has been my explanation and diagram for constant pressure calorimetry. Thank you.